Hey folks, problem number 2. Very similar to problem number 1. I noticed that the data is matched. And by matched, I mean it's matched pairs. Person number 1, 2 scores. Person number 2, 2 scores. Person number 3, 2 scores. Okay, so the data is matched. So every person has 2 readings. And we're just keeping track of their weight with this new diet pill called Trim Spa. So there's their weight on the placebo, their weight on Trim Spa. Now this always throws people for a loop. The way I set things up, I put the placebo on top, Trim Spa weight on bottom. That way when I subtract, tell me if this makes sense. The first person, when they're on Trim Spa, the diet pill, the first person lost 10 pounds. Second person lost 15 pounds. The third person lost 5 pounds. A fourth person didn't lose any weight. And then that last person lost 5 pounds. So the way I set things up, I'm keeping track of pounds lost. And so if the diet pill is working, I want to lose a lot of pounds. So if Trim Spa is working, then I'm wondering if the mean difference is big, if it's more than 0. If it's equal to 0, then that means Trim Spa has no effect on your weight. What's the effect on your weight? None. Alternative hypothesis. What's your mean weight loss, the difference, the pounds lost? Oh, it's more than 0. Oh, that means the diet pill is really working. Okay, so that's the first idea you need to wrap your head around. Some people are really annoyed by that. They're like, but we're trying to lose weight. Shouldn't it be less than? And I go, yeah, but the way I set things up, I wanted to just subtract down so that I'm keeping track of pounds lost. You see how that big number, that positive number, indicates that Trim Spa is working. That big positive number indicates that Trim Spa is really working. Oh, so the positive numbers are indicating that the Trim Spa is working. Okay, let's see if we can get our head wrapped around that idea. And then from there, I think it's just throwing it into your calculator. So test that. P-val, statistical conclusion in English. Okay, let's throw these numbers into our calculator. So stat, edit, because we're going to put numbers in a list. L1, let me go up, hit clear, hit enter. Okay, nice and clean. Let me give it the numbers 10, enter, 15, enter, 5, enter, 0. Do you have to put 0? Yeah, of course. 5, enter. Okay, all the numbers are in there. And it's just a t-test. So a stat, tests, t-test, enter. Data or raw stats? We gave it a big list of data. Okay. The mu naught, yep, it's 0. I put everything in L1. Frequency is just 1. Every number appears once. And greater than, okay. And then hit calculate. So test stat, don't just write 2.7456, write t equal 2.7456. I just arbitrarily went out to the 4th place. You could have called it 2.746 if you wanted, that works. P-val right below it, 0.0258. Again, just went 4 places randomly. Alpha significance level is 0.05. So how does that 0.0258 compare to our alpha of 0.05? It is less than. Our p-val is less than our alpha. If p-val less than alpha, we would reject the null, reject HO. Here's our HO. Let's reject it. Evidence suggests the mean weight loss is more than 0. Evidence suggests the Trim Spa works. So, because we're wondering if Trim Spa helps with weight loss, evidence suggests Trim Spa helps with weight loss. So we're just putting it in the context of the problem. You could have said evidence suggests the mean weight loss is greater than 0 when using Trim Spa. But I think this is a little bit simpler. Evidence suggests the Trim Spa helps with weight loss. Okay. Hopefully you're realizing that this isn't too crazy. It's just like What did we say? It's just like 9.2, except there's one extra step. Subtract in the very beginning. Okay, no big deal.